So today we're going to begin by discussing angles and degree measures in the unit circle. We already did an investigation with the unit circle on Desmos, and so now we're going to add some content to that and just kind of continue to talk about unit circles in the entire chapter. So today's main topic is going to be the angles that are created in the unit circle. So this positioning of this arrow is called the initial ray. And it is where you start before you do the rotation of whatever angle you're going to in the unit circle. So let's say we're trying to go to 110 degrees in the unit circle. What I would do, and again, it's called a unit circle because it's a circle whose radius is 1. So picture, I'm going to rotate this ray until I get to 110 degrees. So far I've rotated it 90, and then I have to go a little beyond 90 to get to 110 degrees. So here we have 110 degrees rotation approximately. And so picture if I had a circle, that would be our unit circle. I'm just going to sketch it in there. And then we rotate around the circle however many degrees. So the positive position is counterclockwise, which seems counterintuitive because it's like, well, why would counterclockwise be positive? And I asked a mathematician that once, and he just said, well, clocks are wrong. So yeah, I don't quite get that, but that's what he said. So that's how you rotate in the positive direction. And we have our initial ray. That's where we always start. Where we end is called our terminal ray. So terminal just means ending. So we have our terminal ray and our initial ray. Now we can also rotate negative degrees. Negative degrees means we go in the opposite direction. So if I wanted to go, let's say, negative 70 degrees, I would grab my initial ray and rotate it until I get to 70. So 90 is straight down. That's our right angle. So I want to be a little bit off of the 90. And so that is going to be representative of negative 70 degrees. And obviously I have to do a little estimation there. Maybe I want to rotate it a little further because I only want to leave 20 degrees. And again, we can picture the circle, the unit circle being drawn for this, or, you know, it's not really all that necessary to have this circle drawn at this point, just to talk about direction. So again, the positive direction is counterclockwise, the negative direction is clockwise. And we can go around the circle any number of times, and you would just keep counting up the degrees, kind of like, you know, a clock. So angles can be considered anywhere. In geometry, we learn of angles and triangles. We learn of angles and really all these different shapes. But in trig, we consider the angles on a unit circle because it just makes all the math a lot easier. So angles have two different ways, two different units. They can be measured in both radians and degrees. So if I take a look at this particular angle, like right here, that's going to be about 60 degrees. So that is the number of degrees. The number of radians is the length of the arc. Okay, so that is going to be the number of radians. It is the arc length that you get when you rotate from the terminal, from the initial ray to the terminal ray. So the length of that arc there is going to be the angle measure in radians. So let me describe how to calculate that. So the arc length is all dependent upon what fraction of the circle. Well, how many degrees are in the whole circle? Yeah, so we have gone 60 out of 360 degrees. In other words, 1/6 of the circle. 1/6 of the circle. So the entire perimeter, or the circumference of the circle, is found by doing 2 times pi times the radius. And in this case, it's a unit circle, so it's 2 times pi times 1. So our radius is 1. So the whole circumference is equal to 2 pi. But we've gone 1/6 of the circle. So 1/6 of, so that's times the 2 pi, will tell us how many radians. So that's going to be 2 pi over 6, because we multiply across, and so we get pi over 3 radians. So that's how you calculate radians, and we're going to find a much faster way to do it, but it is the length of the arc that is carved out by the circle. So 60 degrees is the same as pi over 3 radians. So pi over 3 is approximately 1 unit, because pi is like 3.14. 3.14 divided by 3 is about 1. So about 1 radian. So notice it's kind of weird because degrees is really a rotation, whereas the radians is actually a length. But those two are two different units to measure an angle. Now, because this is so related to the movement of a clock, you can convert decimal degrees into minutes and seconds, much like, you know, if I were to say the time right now, I would say 11:07 and like 30 seconds. So 11 hours, 7 minutes, and 30 seconds. So the degrees, when we think of it, is kind of like the hours. And then we have to convert the decimal part, the 0.57, into minutes and seconds. So this is how it works. We know, just like with time, there are 60 minutes per 1 degree, and there are 60 seconds per 1 minute. Oh, I don't know why I put a degree there. 60 seconds per 1 minute. Again, just like time. So the way we calculate this decimal of a degree is we take the decimal part, which is 0.57, and multiply it by 60 to get the minutes. So 0.57 times 60 gives us the minutes. And I get 34.2. So 34.2 minutes. And then what you do is you take the remaining decimal, which is 0.2 minutes, and then times 60 seconds per 1 minute. So it is the steps of taking the decimals and breaking them down to smaller units. So we take the decimal in degrees, break it down to minutes. Take the decimal in minutes and break it down to seconds. So that's going to be 12 seconds, I think. Let me just make sure. Yeah, that's right. So there we go. So we have the number of degrees right here. And this is because the minutes cancel here. All right, so we have the number of degrees. That's the whole number here. We have the number of minutes, and we have the number of seconds. So what we're going to do is put it all together as 35 degrees. 34 minutes. And 12 seconds. Now, instead of having to write the minutes and seconds out each and every time, they use a little shortcut. So they say 35 degrees, 34 minutes, and minutes just gets a little like tick mark, kind of like we measure feet and inches, and 12 seconds, and seconds gets 2 tick marks. So that's just the fast way to write it. 34 degrees, 35 degrees, which is what we had initially. 34 minutes, which is our whole number for minutes. 34 minutes. And then 12 seconds. Okay, questions on that? Okay, so that's how we do a conversion. And it's basically me like saying, oh, we have 1.5 hours until the movie. It's like saying, okay, now we have 1 hour and 30 minutes. So it's just a different conversion for the degrees. Now, you also need to know how to go from degrees, minutes, and seconds to the decimal form. And so we can see this, the 41 is the minutes, and the 12 is the seconds. So we need to consider 2 different conversions for this. So we are putting this in decimal form. So the 13 stays the 13, plus we have to add on the minutes. It's going to be 41 out of 60 for the minutes. And the reason you divide by 60, because there are 60 minutes in a degree. So 41 out of 60, because there are 60 minutes in a degree. And then plus 12 out of, and how many seconds are there in a degree? So 60 seconds in a minute, and then 60 minutes in a degree. So 60 times 60 gives us that 3,600. So we get these numbers because there are 60 minutes in 1 degree. That's where this 60 comes from. And then we get 3,600 seconds in 1 degree. Much like there is 3,600 seconds in 1 hour, or 60 times 60, there's 3,600 seconds in 1 degree. So then this is where we bust out the calculator and we can just type all this in. And I get it. I'm going to have to do a little rounding. Okay. 13.687. And that is the decimal form. So for this next one, the whole degree stays just 24. Then we convert the minutes to degrees by dividing by 60. And then we convert the seconds to degrees by dividing by 3,600. So 24 degrees, 56 out of 60 degrees, plus 6 out of 3,600 degrees, because you've converted them all to degrees by dividing by their conversion factor. Okay, and I get 24.935 degrees. So that's just dealing with the different ways that you can represent degrees, just either as a decimal or in minutes and seconds. And if you're dealing with navigation, they use minutes and seconds, like in a plane or in a boat. So it's a very useful use of this particular concept. So we already talked about today that it is 360 degrees to go around the origin. So as you travel from your initial ray, which is again the positive x-axis, if we're traveling, and we did this a little bit in the investigation, we can travel in the positive direction. And if we go up from here, here is our 90-degree mark, and then another 90, so that's our 180-degree mark. Another 90, 90 plus 180 is 270. And then if we finish off our rotation, 270 plus another 90 gives us our 360. So that is one trip around the unit circle. Again, 90 and then 180, 270 and then 360. But if we want, we can continue to rotate. Like I could go to 370, I would stop around right here. That would be 370 degrees going all the way around and then 10 more. So just because you can stop at 360 doesn't mean you have to. Like you can keep going and represent angles in multiple ways. So we can use angle measures that are really any degree. We know if we go negatively around that we can also reach all of the parts of the unit circle. So there's many ways to represent the same terminal ray. So for example, how many degrees is 6.75 rotations counterclockwise? Counterclockwise is our positive direction. So if I want to count up rotating this puppy 6.75 times, I can do 1 rotation, 2 rotations, 3 rotations, 4 rotations, 5 rotations, 6 rotations. So that really is like we, didn't do anything. So 6.75 rotations counterclockwise is going to be 6.75 times 360. So that angle, if I do the multiplication, 6.75 times 360, that's 2,430 degrees. But that's like way big. Like, why would I want it that big? So if I consider rotating it 6 times, I'm back where I started. So rotating it 6.75 times is the same as rotating it 0.75 times because you just end up where you started. So to go 0.75, I could go, this is a quarter. This is halfway around my rotation. And this is 0.75 because I've done a quarter, a half, 0.75. So how many degrees would this be? Yeah. So that means 2730 degrees is the same as 270. It's just a lot more convenient to represent it with a lower number because you can imagine what 270 looks like. I can't really imagine what 2,430 looks like. But you can certainly do the rotations. I mean, we rotate around the clock twice a day, every day for eternity. So, it's just kind of the way things are. So if we look at how many degrees is 3.5 rotations clockwise, clockwise is the negative rotation. So to find how many degrees it is, I can just take 3.5 times negative 360 because I'm rotating in the negative direction. So doing that multiplication, that's going to be negative 1260. So if I actually do it, oh, that doesn't work. Let me get a true arrow here. Okay, so if I take this, we know, let me just rotate it. So this is going to be -1 rotation, -2 rotation, -3 rotation, and then -3.5. So that's clockwise. So how many degrees would that be normally then? What is that equivalent to? Yeah, 180. And you can actually call it positive 180 or negative 180. It actually gets you the same thing. So this is how many degrees it is, but then we can see an equivalency that's a lot less, a little more convenient to use. So this is a definition. A coterminal angle is an angle with the same terminal side. So for example, this looks to be about 30 degrees. That would be the rotation from the initial ray, which is the positive x-axis, to here. So if I consider what angles are coterminal with 30 degrees, well, one thing I could do is I could rotate a full 360 and end up where I started. So if I take this and I rotate it, here's, whoops. So here's 30, but if I kept going, how far have I rotated to get back to the same terminal ray? So what's coterminal with it? So again, if I would start here and rotate once around and end up at 30, how many degrees would I have gone? 360, and then plus the 30. Yeah, so 390 is coterminal. So that's one way to find a coterminal angle. Another way is, let's say I start here, but instead of going in the positive direction, what if I went in the negative direction? How far negatively would I need to go around to get to 30 as well? So we start here, and then we're going to rotate it. Here's -90 down here. Yep, -360 gets us all the way down here. Yep, so it's actually -330 because we stop before we complete the whole circle. You stop 30 degrees short. So 390 and -330 are both coterminal with a 30-degree angle because they both get you to the same spot. It's just like taking a different path. Okay, so let's name two angles that are coterminal with 205. So I'm going to need a unit circle for this. So if we look at first quadrant, second quadrant, third quadrant, and the fourth quadrant, where is 205? Beautiful. So I'm going to start in my initial ray, and I'm going to rotate until I get to 205. So here's 90, here's 180, and then I need to go a little bit beyond that, about 25 degrees beyond that. So 205 is right here. So the angles that are coterminal with that, well, one way we could do it is we could rotate in the opposite direction. If I start here and rotate in the negative direction, the angle degree to get from my initial ray, which I have in red, to here would be how much? So -360 would take us all the way around, but I want to stop right here at this blue ray. So this is -90 here. -90 from the start. So negative 180, we'd pass it a little bit. We'd be right here. So the way we can figure it out is we can say, okay, well, from here to here, I've gone negative 90, right? That gets me to this spot. That's negative 90 degrees. And how many more do I need to go to get to the blue ray? This part in here is going to be 25 degrees. Is that right? Yeah. So it looks like I have to go 65 more to get here, because 25 plus 65 gets us that 90. So it's going to be negative 155 degrees is another way to go. And one way you could figure it out is you could just say, okay, I'm going, is just take 360 and subtract off that 205. And that's going to give you the amount you've gone. So that's a negative coterminal angle. The way to get the positive one is just really, you just have to add 360. Adding 360 indicates that you're just going to do an additional rotation. So if I start with my initial ray here, and we know to get to 205, you rotate here, but I'm going to pass it, do a full 360, and then rotate again to 205. So it's basically I go once around and then back to 205. So to add 360 will tell me what that is. So 360 and 205 gives me 565. So that's another coterminal angle. So in summary, finding coterminal angles, you can just add 360 or subtract 360. And that just means you're going to rotate a different direction or rotate a full amount before you go to that terminal ray. Okay, next question. If an angle measures 595, what is the coterminal angle that is between 0 and 360? So for this one, you have to consider that 595, first of all, is not between 0 and 360. So if I take that 595 and subtract off 360, I'll be subtracting off a full rotation, but I won't be changing the angle, because a full rotation takes you right back where you started from. It's kind of like when someone says, oh, I did the opposite that I thought I was going to do. I did a 360. Well, that's not doing the opposite, because if you do 360, you end up right where you started from. So if you take 595 minus 360, you know that angle is going to be 235 degrees. So if you add 360, if you subtract 360, all of those angles will be coterminal, because you're just rotating another time and getting to the same spot. All right, so right now we're going to work on some practice with angles. So we're going to practice coterminal angles and then also converting from minutes to seconds.